Okay, I'm going to do an example of another of our addition reactions with sulfuric acid as the strong acid. So this is similar to the example we did in class the other day with HCl, except this is using H2SO4. And so this would be concentrated H2SO4 with the assumption that there's no or very little water present. And so without even going through the mechanism, we would very quickly see that this would be a Markovnikov addition. Okay, and basically we're going to have hydrogen added to one side of the pi bond and then HSO4 added to the other side of the pi bond. And of course, this is going to be what's going to be the nucleophile. This will be the electrophile. So the electrophile will get added to the less substituted side of the double bond, and the HSO4 would be added to the more substituted side of the double bond. So if we're looking at what gets added, I'm going to draw in my hydrogen atoms that were already present in the current color. And then the new hydrogen atom would get added to the right. And then if we probably need to draw what this is, of course, bisulfate anion. What that looks like. So once the proton gets taken off, this is what sulfuric acid looks like. If we take the proton off, then we're left with this. But of course, this is going to make, these electrons are going to make the new bond to the carbon on the left vinylic carbon atom. Okay, so that's what that's going to look like. If we want to go through the mechanism, however, we can do that. We know the mechanism for this is going to be electrophilic addition, followed by followed by coordination. So this will attack here. These electrons go there. And we want to put the proton on the less substituted side. Which is going to put our positive charge here on the more substituted carbon. That's going to give us a secondary carbocation that would be more stable than a primary carbocation, which is what we would get if we added to the other side. And now the nucleophile that we've created is going to look like this. Again, it's going to be that bisulfate anion. And that's going to attack here. And since this is trigonal planar, the carbocation is sp2 hybridized. The bisulfate can go either top or bottom attack. So what we're going to do is we're going to draw this both ways. So this will be coordination. If it's okay with you guys at this point, I'm going to go ahead and do a couple of things. I'm going to get rid of drawing all the hydrogen atoms, and then I'm going to abbreviate the bisulfate anion in the following way. I'm going to go ahead and pull out one of those oxygen atoms and show that that is what is bonded to the carbon atom of our pentane. And then we can either say plus En And this would be our final answer. This would be racemic. And this would, therefore, since it's racemic, we have an even mixture of the two enantiomers. So the specific rotation would be 0 degrees for the optical rotation.